Continuing on with 2.4, a new form of showing quadratic functions called standard form, where it's y equals and then whatever number x squared, whatever number x, whatever number. Okay, and we talked about how to go from vertex form to standard form by just sort of multiplying out and simplifying. Going backwards from standard form to vertex form is a little bit more complicated. It involves some factoring. And I talked about, at the end of the last lesson, a perfect square trinomial. And a perfect square trinomial is a trinomial that can be factored to two identical binomials. So, for example, if we had x squared plus 10x plus 25, and I factored that because it's an x squared trinomial, I would get x plus 5 times x plus 5, or x plus 5 squared. So that would make this would be called the perfect square trinomial. And why do we need to know this? And why do we need to know how to do this? Because if you look at this, this is part of vertex form of the quadratic function. Now, the not so nice thing is when you're given a function in standard form like this is, it's not a perfect square trinomial. If you tried to factor x squared plus 8x plus 5, you can't do it. Okay? Not only can you not do it, it wouldn't even give you two identical binomials. So we have to create one. And we create one using the x squared term and the x term. We don't use the number 5 to create a perfect square trinomial. So I'm going to put it at the end. And you remember we talked about how to create one. What number could I put in here so that when I factored these three terms, I get two identical binomials? Do you remember how to find it? Sorry? Take the x term, divide by 2 squared. So that means plus 16. There's the trinomial we can factor. But I changed the expression, didn't I? I added 16 to it, so I created a new expression. How would I balance that out? If I add 16, what else would I do to cancel them out? What's that? Subtract 16. Like I've added 16 and subtracted 16, but in effect I've added nothing. It's just I need the 16 to do the factoring. So that's why whatever number we add to make the perfect square trinomial, we've got to subtract that same number. So now notice we've got this set up so we can factor. X squared plus 8x plus 16 factors to x plus 4 times x plus 4. These two can be combined to make what? Negative 11. Well, x plus 4 times x plus 4 is just x plus 4 squared. we've got ourselves text form. So that's the process. Is you have to figure out, you got to make a perfect square trinomial by adding a certain number, and then you got to subtract that number to keep the quadratic function balanced. And then you factor and simplify, and you've got yourself vertex. What's the vertex of this? Just as a review. Where's the vertex of this? Sorry? -4, -11. Good. Okay. What's the equation of the axis of symmetry? X equals -4. Okay. Does it have a maximum or minimum? Minimum, because it opens up. There's no negative. At y equals -11. Good. Okay. Just want to keep reinforcing that. I mean, that's going to be a big chunk of what you're going to be testing. Okay. So I just want to practice with a few more of these. So I'd like you to try this one. On your own or with somebody else is fine. Before we get into a little bit more complicated. So see if you can do this one. All right. So you can keep it as f of x or y. I'll keep this one as f of x. So the way I set it up is these are what are going to complete the square in addition to a number. So that's why I separate these first two from the number, because this has nothing to do with completing the square. What am I going to add and subtract? 25. So plus 25 minus 25, parenthesis off the three terms you're going to factor. This works out to x minus 5 times x minus 5, or x minus 5 squared, minus 26. That's it. Okay. Okay, the next couple. Let's have a look at this one. How does this one look different from the previous two we did? It's got a negative x squared. I can't have anything in front. Okay? I can't have the negative because I can't complete the square if it's negative x squared. If there was a number in front here, I can't complete the square. So what I'm going to do is I'm going to remove it from these terms that I want to complete the square on. So I'm going to use y equals. So how do I remove it? Factor it out, as in GCF. So imagine you're dividing by -1. This becomes positive x squared now, right? And this becomes negative 2x. And remember, the -5 is way out here. So notice I had to do GCF so that I could get a positive x squared there. So now focus on the inside of the parentheses. What do I need to add and subtract? Plus half of this squared is 1, minus 1. Remember, those are still in the parentheses that have been factored. I can't just take this -1 and put it here outside the parentheses because I've already started to factor. So what I've got to do is I've got to bounce this out. I've got to get this out here because this is what I want to factor. So to bounce it out, I got to multiply it by -1. In order to take it out of the times -1, I have to multiply it by -1. So I've got to times these two, and I get +1. Now this is gone. Now I've got the form. And you don't have to write the 1. You can if you want. So -1 or negative. Now we've got the parentheses to factor. What does this factor to? X minus 1. And these simplify to -4. So you've got to be careful when there's something in front of the x squared. When there's something in front of the x squared, you got to factor that out of the x squared and x terms before you complete the square. And then you've got to bounce the last number out of the parentheses so you can factor correctly. Opens up or down? Down. Okay. All right. This is another one like this, except this time we've got a 2 in front. So I need to remove the 2 out of the x squared and 4x. And by that, I need to factor out 2. Divide 2 out of both of these. What are you left with when you divide 2 out of 2x squared? And then 4x plus 2x. Remember, the -4 is not part of it. It's way over here. And now, focus on the inside of the parentheses and complete the square. Add 1 minus 1. Remember, that's still in the GCF parentheses. So I got to bounce this out. But in order to remove the -1, I got to times it by 2 as I take it out. So I get -2. So I still have a 2. What does this factor to? X plus 1. And simplify it. -6. If you were to graph this, how would you, like, where's the first point you would graph? What's the first coordinate you would graph? -1, -6, right? The vertex. Where would you go from there? Over 1, up 2, because it's times 2. Yeah, good. And then you would go back to the vertex, over 2, up 8, because it's normally 4, but it's times 2. Okay, I'm actually not going to do the last one. I'm not going to get you to worry about that.